Hey, Algebra 1, here with your cool down for lesson 12, where we talked about standard deviation today, a new topic for most of us. And we found out that standard deviation is just like the MAD. It measures the variability of our data set, of our shape, of our distribution. And it's really complicated to find. We didn't get into that. We don't want to go that in depth with this. Wait till you take AP stats to do that. But it is going to tell you and talk to you about how the numbers vary. All right, so let's answer some of these questions that came along. These were true false. We got low temperatures in these different cities, same day in March over the years. So, one day in March in some year it was 7 degrees low in Christchurch, New Zealand. NZ, I guess. I don't know where Christchurch is in New Zealand, I guess. It sounds right. We got Missouri, we got Illinois, and we got UK, London. So we got all these temperatures and March temperatures and their lows. And this is in Celsius, so don't freak out too much about them being a little weird looking. All right. So the first question here, or the first part, is giving you, is this true or false? It says the standard deviation of Christchurch's temperature is 0 because the data is symmetrical. This is a pretty common misconception. People think just because they see symmetry that there's not going to be any variation. Well, that's not true. Symmetry and bell curves are going to show variation. I mean, the dots are not all lined up on top of one number. I mean, you got some on the right, you got some on the left. These aren't going to cancel each other out. I think that's what some people think. Like these 11s cancel out the 9s and the 12 cancel out the 8s. It's because standard deviation, just like mean absolute deviation, they make these distances away from the center positive. So really, these are 1 away, these are 1 away, these are all 2 away. So these are accumulating value. They're not going to cancel each other out. There's definitely variation here. So you can't say that it would be 0 there. That would be false. All right. And yeah, you're right. My daughter, she looked it up. NZ does represent New Zealand. So I was correct in my guess there. So it just true or false is all you have to write for these, but you also have to explain your reasoning. So if you just wrote true or false, you're not going to get full credit here. So why is this false? We're going to say it's false because the plot does show variability. If it was 0, that means there would be no variability, it'd just be a stack all on the same number. So it does show variability, so it can't be 0. Let's move on to the second one. The standard deviation of St. Louis's temperature is equal to the standard deviation of Chicago. Let's look at these two cities. So here's St. Louis, here's Chicago, and if you notice, this is what you have to be looking for, because remember, variability is not about where the middle is. It's about how the numbers are spread out. And if you look at it, 1, 3, 1, 1, 1, 2, 3, 4, 5, like 1, 3, 1, 1, 5, skip 1, and then another dot, and then a tower of 5 again, and then dot, dot. These are the exact same graphs. The only difference is that Chicago is shifted downward like 3, right? So if you want to relate it to what we're doing in 8th grade math, it's like it's been translated from here, to there, the entire graph and all of the dots, right? So when you shift it like that, you're not really changing the variability. You're just changing the mean, or you're changing the median. So whenever these shift over like this, the variability is going to stay identical. And you should have noticed that when we did it in class, when we had the data sets that were like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, if you want to keep the same standard deviation but change your mean, you could just make it 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and just have your numbers all shift together but stay the same distance apart. So this is actually going to be true, okay? And we need an explanation here. Why is this true? All right, it's true because the spread is the same, just a different mean or median. So the spread is still the same. How the graph is spread out, it's just over a different number. So that's not going to affect the spread. The spread represents the standard deviation, variability. All right, let's move on. Number 3, the standard deviation of Chicago's temperatures is less than standard deviation of London's temperatures? Well, let's look at this. So Chicago versus London. Chicago and London, you'll notice, very similar. Excuse me. Everything's identical, 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 except the last dot for London has been shifted over to 8. How's that going to affect the standard deviation? Is that going to make London's standard deviation be bigger? Is that going to make it be less? Well, it's spreading the numbers out more, so it should increase the variability. So London should have a higher standard deviation than Chicago. Let's look at the statement. It said the standard deviation of Chicago's temperature is less than the standard deviation of London's temperatures. So that is a true statement. That is a true statement. And we know that's true because the final value in London is farther from center than Chicago's. That's how I know. If it was closer to the center, then London would have had a lower standard deviation. But since Chicago's was more tightly bound together, that gave it a lower one. So just that single point, we noticed that just changing 1 point, it's going to affect the mean and it's going to affect the standard deviation. This one's got more variability because there's more spread, wider range. This one's identical except for that one change. And so it's going to affect it a little bit, not a whole lot, but it is going to be less in Chicago with variability than it would be in London. All right. I hope this video was helpful. I know it's kind of long, but there was a lot to kind of get over there of what we discussed in class, but I think you guys are going to be fine on that quiz. We'll see you tomorrow.